Hi everyone, welcome to Chapter 5. In Chapter 5 we're going to do a two-group t-test of the difference of the means for independent groups. This is as opposed to Chapter 4 where we did a one-group t-test. So in this chapter we're going to do a two-group t-test. A subtle but important difference. We're going to have two videos for Chapter 5. We're going to have one for groups where both groups you're going to study have more than 30 participants, and you're going to have another video where both groups are less than 30. It's very important, as in all chapters, that you do all the reading prior to going through this sample. And in this case, they go step by step on how to do this, starting on page 81 in the text. And I'm really going to pick up with the example that starts here on, I'm on page 92. And I'm going to go ahead and enter everything in and set up the problem as they have it set up. And we'll go ahead and solve this one. Okay, for what we're looking at here is we have two groups of boys, is what the problem that on page 92 starts with. And each group, well, one group is given Coke and one group is given Pepsi. And the two groups each rate their experience with the drink on a scale of 0 to 100. And once again, this is on the top of page 92. And the results from those tests are there at figure 5.8. You can see there's 52 boys tested Coke with a mean of 55. That's a mean score from 0 to 100 and a standard deviation of 7. And then you see the scores for Pepsi as well. So let's go ahead and get this worksheet set up. So let's see, where do they have? They have this putting group into cell B3. Once again, not too sure why they have everything slid over. So let's go ahead and cell. Okay, we got group, and then we're going to go 1 Coke, 2 Pepsi, and then we're going to have N 52 and 50, oops, not 27, 57. And then we will have mean 55 and 64. And standard deviation of 7 and 13. They centered these, so let's go ahead and do that as well, just like in previous chapters. And we're going to go ahead and set up our null hypothesis. And what do they have? That's in cell B8. All right, I'm in the right spot. So we're going to have the null hypothesis. And then right below that, we're going to have the research hypothesis. Okay, let's go ahead and adjust the column width for that. And let's go ahead and type it in. And in this case, we're going to compare means. So we have group 1 is Coke, group 2 is Pepsi, and what we're going to decide with these scores is if the two groups of boys scored the drinks equally. So if you look at the means, they scored Pepsi higher than Coke, 64 to 55. But when you take standard deviation into account, which means the dispersion of the scores, is there a statistical difference in their scores? Because you can look at this, and we could probably guess the result here, that the 64 is in fact significantly different than the 55. We can guess at that. We could be pretty sure just by looking at it. But what if instead of 64-55, we had 61-59? Would you be willing to say that that was a significant difference? Maybe, maybe not. So that's what we're doing here, and to set this up, I'm going to go ahead and use the proper symbol. So I'm going to go Insert, Symbol, and I'm going to look for the symbol for mu, which looks like a U, but it's Greek. And I'm not seeing it here, but I know it's on here somewhere. Now, many of you may have noticed that it's in my recently used symbols. That's how I know it's in here, because I've used it, but I want to find it in the list so that all of you know that you can find it in that list as well. I hope I haven't passed it. I'm only going to spend so much time looking here, and then I am probably, for the sake of time, there's some U's there. That doesn't look like it. Choose where I may choose where I've already found it. Just because I know it's in there somewhere. I don't see it right now, so I'm going to just go ahead and pick it out of this list. It's only in this list because it's up in here somewhere. I just don't know exactly where. And I don't want to go on and on. And it would be U group 1. Now remember, 1 is a subscript, so I'm going to highlight it, format, subscript, hit OK. And that's going to be the equal sign. Oops. Hit enter. And then rather than look everything up again, I'm just going to copy that. I hit Control C. Nope, it's not letting me. Control C, and then copy it over here. And then I'm just going to copy it into all 4 spots. This is for the sake of time. And I'm going to replace the 1 with a 2, actually. And then I'm going to copy that and paste it here. And in here, we're going to need the insert symbol not equal to. Now, you may say, well, we're going through a lot of trouble just to get those symbols in there and have it look like this. What I just did is not absolutely necessary for solving these problems. You don't have to do this part to get full credit. It's just a nice thing to have done. And so once again, it's completely your choice if you want to invest time into that. It makes it look a little fancier if you're in the workplace. Makes it look a little more formal to actually have the Nolan research hypotheses set up correctly. Okay, let's continue on down. We're going to skip a couple lines as per the sample, and we're going to go standard dev1 squared over n1, and that's going to and then we're going to go ahead and we'll do the formula in just a second in where we're supposed to do it, but I'm going to go ahead and just copy all of these formulas and everything you see there from page 94. So what this is doing is we don't have an Excel formula to calculate the 2-group t-test from given data like this. So instead of putting in Excel formulas, we're simply putting in what we were going to type into Excel to solve appropriately. That's all we're doing here. And so the book was pretty good about setting up everything here so that we can see what we're doing, what we're going to do in the actual formula cells in column D. Okay, now we're ready to actually enter in the formulas. I'm going to go into column D, and we're going to go equals open parentheses E4, so the standard deviation of 1. So your line, this is the standard deviation of group 1, E4 to the power of 2, which is squared, and that is going to be shift 6 2. Okay, so you get that little arrow 2, close parentheses, divided by C4, which is N1. So you could see how we just created the numeric formula from those words over there in B13. We're going to hit enter. There's your score, your value. We're going to go ahead and do something very similar for the one below it, but with group 2. So we're going to go equals, open parentheses, E5 to the power of 2, so shift 6, 2, close parentheses, over C5. Okay, there's your value. Then we're going to go D13 plus D16 equals D13 plus D16. And then we're going to do the standard error, which is a little different here, equals square root, open parentheses, D19, or you can back up and just select D19, close parentheses. And then we got to our critical T. We're going to use that T inverse equation we did from the last chapter, rather than the book says just put in 1.96 or look it up in the chart at the back. I think this way is easier because you don't need to look anything up. T point inverse dot 2T open parentheses 0.05 comma degrees of freedom is going to be your numbers minus 2, since we have two lists. And up here you can see our numbers are 52 and 57. That's our two group numbers. You add those together, you get 109, 52 plus 57. And then you subtract 2 because there's two groups. So we put in 107. 109 minus 2 is 107. Close parentheses, enter. And then for our t-test, we're going to go ahead and do this with absolute value built in, rather than just assume it's the absolute value of this number. We talked about this in the last chapter. I went and showed you how to do the absolute value, add that to the equation after the fact for chapter 4. I'm just going to include it now. So we're going to go equals ABS, open parentheses. Actually, we're going to do a double open, two parentheses, and we're going to go D4 minus D5, close parentheses, divided by D22, which is the standard error, close parentheses, enter. Okay, now let's go ahead and fix the decimal points on all of these. So I'm going quick through this because we've already done it, and I kind of expect everyone to remember how to do these things. So I'm going to go home and then reduce my decimal points, so I'm at 2 decimal points throughout. Okay, so what does all this mean? So they gave us the number, the mean, and the standard deviation for the two groups, and then we did our calculations. You don't really need to worry about any of these calculations. We just had all of these to get us to these two, right? We're really specific to get us here. So we only really need to analyze those bottom two. So you've got 4.55. Since 4.55 is larger than the critical T of 1.98, we are going to reject the null hypothesis and accept the research hypothesis that the two groups are not equal. Two groups are not equal. So the boys do in fact rate Pepsi higher than Coke. So we are going to type out the explanation, and the book did a nice job with this, so I'm just going to use how they explained it. Since okay, by the way, I'm on page 96, typing in the result on the bottom of page 96. Since the absolute value of, I'm just going to put 4.55. They put negative 4.55, but since we did the absolute value already, it's not necessary to put the negative sign, is greater than the critical T of 1.96, we reject the null hypothesis and accept the research hypothesis. And the conclusion, so putting this in plain language, and since, where are we going to get our conclusion? Since we can see that the mean of Pepsi is higher than Coke, and since the t-test here is bigger than the critical T, we can say that the mean of Pepsi is significantly higher than the mean of Coke. So let's go ahead and put that in our conclusion. So we're going to say teenage boys, actually boys isn't capitalized, I want to do it right, rated the taste of Pepsi as significantly better than the taste of Coke. 64 to 55. And that would be a correct statement. So that's how you do a two-group t-test. Now, there's another way to do similar problems, which I'll show you in a few minutes. If you have two lists of numbers. Because you see they gave us the number, the mean, and the standard deviation for each group. But what if instead of doing that, they simply gave us two lists of numbers? They gave us all the scores and we had to calculate all of this data on our own. And there's a different way to approach this when you are given the raw data, and we'll do another video on that in a minute. So this was it for Chapter 5, Part 1.